Awesome. So before I begin, I always like to learn a little bit about you before I begin. So a quick poll. How many people are deployed in the public cloud? All right. How many people are deployed in more than one region? Okay. How many people are deployed across 2 public clouds? Awesome. We'll have to share some war stories after this. So, before we begin, I always like to start with why do you even do multi-region, right? And really understanding why helps you frame the conversation. And so first, it's there's many reasons. There's many reasons you could go multi-region. The most obvious one that everyone thinks about is disaster recovery or failover. And so availability and resilience is a reason. Failure containment, so that you can lower the blast radius of any one region going out. And then there's other reasons like lower latency. There are some use cases that actually merit and need lower latency, so you need to have that global footprint. That said, there are many roads, many strategies, right? You've probably heard of terms like island model, lower latency, as I mentioned, active-passive, active-active, N+2. N+2 is fascinating. N+2 is from Google. That if N is the amount of regions that you need to serve your customers, they provision 2 extra. That way, they can decommission and tear down 1 for maintenance and still lose 1, and they're okay. And so that's an N+2 architecture. So that being said, I came across a quote from The Art of War. Strategy without tactics is the slowest route to victory. Tactics without strategy is the noise before defeat. And so you see, for any effort, the hope is you create your plan, and here's your either your Gantt chart or whatnot, even your Kanban board, and you hope that everything goes smoothly, and you end up like this, right? That's the aspirational hope. Strategy without tactics looks something like this. You kind of know where you're going, you're hoping to get to that green dot, but you don't necessarily know the tactics to getting there, and so you might take a route that takes you a long time to get there. And then tactics without strategy, you might get somewhere very quickly, but you might end up in the wrong place completely. And so even if you have great strategy and great tactics, the reality looks something like this, right? You're making progress, you're always taking a step forward, and you probably might take a misturn or misstep and have to correct for that. So when I was preparing for this talk, one of the things I've realized is I've actually forgotten what it's like to operate in only one region. It's been 5 years since I've only had to worry about one region. So how many people are operators? Operators? Awesome, so you guys probably carry the pager. How many people are devs? Awesome, you guys should carry the pagers. And then how many people are managers? Great, I'm a manager too. You definitely need to carry a pager. It does amazing things to your prioritization and your backlog when the manager carries the pager. So in our time together, I'm going to talk to you about a few stories with the goal of equipping you with a couple different strategies and many tactics. And so my story starts at Netflix. I like to say that I grew up as an engineer at Netflix. My claim to fame is actually a team that I assembled and built called Chaos Engineering. So you might have heard about these simians. So the years, and this is kind of a timeline of chaos. Chaos Monkey got built in 2009. I got to Netflix in 2010. And I was quickly acquainted with the likes of Chaos Monkey. I was an engineer, and it was why are my servers going away? So for those of you who don't know, Chaos Monkey looks for groups of servers, or instances if you're in the cloud, and randomly terminates one every day on purpose during business hours, right? Because it's better to lose an instance at 3 p.m. than 3 a.m. And so, I get to Netflix, and it's that's really unfair. Is this really necessary? I'm losing an instance every single day? It felt very unfair. Little did I know that years later, I would actually create a group called Chaos Engineering, and we created Chaos Kong, because if it wasn't already unfair to take away an instance, We actually took away an entire region. So you see, chaos engineering is about intentionally trying to break the system. It's making the choice to discover the failure modes of your system on your terms, rather than letting your customers discover the failure modes of your system. Chaos is really the validate and trust but validate. You know, on the topic of multi-region, the worst time to find out that your multi-million-dollar multi-region DR strategy doesn't work, the worst time to find out that it doesn't work is during a disaster. And so that was the notion. You had to practice these things. I put the years on this slide because you know you hear these talks from Netflix and you're like, wow, like that's amazing. I could never get there. The reality is it took 5 years for Netflix to go from Chaos Monkey to Chaos Kong. You see, resilience takes time. Chaos takes time. And multi-region especially takes time. So chaos engineering and Chaos Kong. In 2014, chaos engineering successfully executed 12 regional evacuations with 0 downtime. Netflix is deployed across 3 AWS regions, 2 in the US, 1 in EU. And see, this is the interesting thing when you actually exercise regional outages this often. When it actually happens, it's a non-event. This gave us such a high degree of confidence that when a real regional outage happened, whether it's a hurricane, whether it's a software bug, whether it's an Amazon issue, we could actually just evacuate at first sight. And so a lot of times your pager goes off, it might be 3 a.m. in the morning, and you're looking at your dashboards, and you're going to try and go figure out what's going on to take corrective action. In this case, since we had this mechanism, we could see, oh, looks like east is affected. Looks like west is not affected. I don't know why. I don't need to know why. Let's just evacuate, right? Like if you think about, if you hear a fire alarm in a building, is the first thing that you do like go find out why there's a fire? No, you get out of the building, right? And so we built that. The systems were built such that at the first sign of an emergency, we could just evacuate. And so that actually changes your strategy from an incident management perspective, because it's start evacuating and then start investigating and figuring out what happened, what went wrong, right? So that brings me to Twilio. And so if you don't know about Twilio, Twilio is a cloud communications platform that it allows developers to build rich communications into their products. So whether it's your Uber driver calling you to pick you up, whether it's Airbnb confirming your reservation, whether it's PagerDuty paging you and calling you. These are just some of the customers and use cases that are powered by Twilio. We have a value at Twilio. You know, every company has values. These are some of ours. One of the values we have is start with why. And you know, remember that thing about strategy and tactics? Starting with why actually allows you to frame a strategy. And so to get started, I have to explain why Twilio is multi-region. So, you know, it's funny, like if 3 regions weren't enough to worry about, like I decided to join a company called Twilio that has 7 regions. And so it was like, and growing. And so to understand this, you first have to understand what it's like without Twilio. You see, the old approach to making phone calls and SMS, you have to negotiate contracts with carriers. Like, they're not accessible over the open internet. You have to negotiate those contracts. Your network team and their network team have to set up interconnections. Then you have to build your algorithms, monitoring, routing, failover. And then you have to rinse and repeat for every different region that you want to go into in order to get that started. It's a very long process. But you see, with Twilio, we got you covered. We've already done all that. And so our distributed software layer actually lets you have the ability to have global reach from the very start when you have just a trial account, right? In other words, multi-region for us is really about quality and market reach. Essentially, we are multi-region so that you don't have to be. This comes with a lot of challenges. And for the purpose of this talk, I'm actually just going to focus on some of the multi-region challenges and not some of the Twilio-specific carrier challenges. And so first, AWS regions are different. The first thing you will find when you start to go multi-region is that the number of availability zones is different region to region. Some regions have as little as 2. Some regions have as many as 5 availability zones. So if your software requires 3, that limits the number. Like, you better make sure that the region you want to go into actually has 3, or you better make sure that your software can run with only 2 availability zones. There are definitely pricing differences. So even if you were on-prem, you would have pricing differences as well, because there are things called customs and taxes in different parts of the world. The cost of power is different. The cost of internet is different. Therefore, the cost of AWS is also different. The availability of services. And so if you're building on some of the high-level building blocks that Amazon offers, the availability of these services may or may not be available across all regions. You certainly have EC2, you certainly have S3, but if you pick some beta new service that you just heard about from reInvent, chances are they're not in every single region. Okay, so you have to know about that. Instance types. Some of the new regions only have the latest generation. They only have C4s and M4s. Right? So if you built an architecture that's like completely based on M3s, not all regions have those. That being said, a lot of the new regions are also VPC only, right? So if you're still in Classic, they're going to try and get you to move over to VPC. The performance is actually different. The network performance, the amount of observed packet lost, the amount of latency that you see, these are all things that are different. And really, the internet conditions in each region are actually radically different. So it's interesting because the maturity of the internet itself, region to region, is very different. So the internet in Brazil is radically different than that of the internet in the US, than that of the internet in, say, Tokyo. The laws around egress are also different as well. So the first tip, this might sound very obvious. Target regions in your alerts, right? So when you're in a single region, you just fire an alert, and you don't worry about what region it is because you only have one. But when you go to many regions or more than one, the first thing that you discover is I get an alert, but now I have to look up, figure out which region it is. So then the next step is put that into your alert itself to tell you what region is actually alerting. When you have 2 to 3 regions, you can kind of get away with a lot because you can scan 2 to 3 regions pretty fast. When you have 5 to 7, you need to get very disciplined about the standardization of how you're doing alerting, how you're doing monitoring. For example, this is a Nagios alert that hits our Slack, and what we have is it always posts the region at the very end every single time. So we know where to look. We know where to start. We also have deep links directly into the correct place and what region off of that alert for everything, right? And so instead of looking at this and just being load the runbook. Well, which runbook? If you have 7 of them, because the regions are different, there's a lot of things. There's a lot of steps there. So when you have many different regions, many things can go wrong. You have a larger surface of things that can go wrong, and so it starts to become additionally challenging to see failure as it happens. Right? It's just a lot more surface to look over, and so the obvious thing you start doing is adding tags to your metrics by region. That's a good start and that's helpful. Availability zone, you can kind of get away with that also when you're only 2 to 3 regions. But when you have 7, that means you have more than 20 zones to look over. And so it's useful to aggregate the regions with their own dimension. But because of these differences, the way that you think about dashboards and the way that you even think about metrics is actually different, right? So if I know that my Brazilian deployment has a different set of Amazon services. There are actually different metrics that are just not coming out of Brazil because of that. And you get started if you have 2 regions or 3 regions. You can kind of put like 3 columns and like put each region in every column so you can scan. But like once you get into 5, 7, your dashboard load times go up. You're trying to scan and know which one you're looking at. Like it becomes challenging. So the way you have to think about dashboards is actually very different. So tip. This might also sound obvious, is automation as a service. So this is not just automation. This is really automation as a service. We actually have a team on platform at Twilio, and we have a service called Lazarus. And this essentially allows you to trigger programmatic runbooks to help teams and developers perform different actions across different parts of the cluster. You see, thinking about 7 different regions in code isn't that hard. Thinking about 7 possible runbooks to manually execute during an incident at 3 a.m. in the morning has human error written all over it. And so the idea is that as we launch new regions, you shouldn't have to rewrite everything. You should just be able to include the next region or parameterize that, right? And so that's why we actually have a team that's building execute runbooks as a service and building extra functionality onto that. So another challenge is traffic and network conditions. If you have things that talk region to region, if you have 2, you only have 1 connection that can go down or have to worry about. When you have an interconnection of 7 to 10 regions, then the number of connections between all the different regions, one of those is failing at all times. Like one of those is either packet loss, latency, something's going down all the time. It's just a lot more moving parts and pieces. And so how your software degrades, how you monitor that, it all changes. It's not just like, it's 7 times more work. It's actually exponentially more work every time you add a region. So to accomplish all this, it's worth mentioning a little bit about the environment of Twilio. So we're a small teams environment. We have 50 small teams. We follow the whole 2 pizza box rule. If you guys have ever heard of that, it's the rule from Amazon that if you can't feed the team with 2 pizzas, the team's too big, and you need to split the team. We're in San Francisco, so it's impossible to actually feed a team with 2 pizzas because someone's vegetarian, someone's gluten-free, someone only eats bacon, it's just impossible. So we have more pizzas just due to dietary restrictions, not due to the sheer amount of food. So, while Twilio we're an API, right? We build an API so that we allow other developers, our customers, to do more with less. That actually permeates through our culture. And so inside of Twilio, it is a culture of APIs. We don't just build software. We always think through the APIs. What are the internal APIs that we need to build in order to scale the system, in order to scale our teams, right? Small teams and APIs go really well together. They're about abstractions in different domains, right? When I was interviewing the VP of engineering, I asked him a question. I was like, how do you maintain culture when you have so many different offices? So Twilio has global offices. We have offices in Europe, like 3 offices in Europe, 3 offices in the US. So we have a global footprint. The sun never sets on Twilio, right? And so I asked him, how do you maintain the company culture when you're the culture of people is so diverse? And his response, I thought, was very, I will say this was a pretty big plus for me joining Twilio. He had a 1-word response: APIs. And you see, the thing he explained is you don't want the culture to be the same, right? The culture of what region you are coming from, the value systems, the culture of different countries, they are different. But the way that you scale a global company is by APIs. And so you agree upon the API, and that is how you interface with the other team's domain. So it allows your systems to scale, it allows your company to scale. So to recap kind of the multi-region takeaways, instrument. All the ops people get it. All the devs, like, you're always gonna be missing stuff. So instrument, practice your instrumentation. You will need more instrumentation in multi-cloud than you think you do. Like, that's always been true everywhere I've been, whether it's Netflix or Twilio, you're always short on instrumentation. APIs. It's not just your front-facing API, internal APIs. That allows you to scale as well, right? That also eliminates the risk of human error as well. And automate. And use an API to expose an API that allows you to trigger your automation and update your automation, right? So moving on to multi-cloud. Why multi-cloud? We have customers in all clouds. And in some cases for Twilio, we actually integrate with the cloud providers. Earlier this summer, we actually announced a partnership with AWS to deliver SNS messages. So we literally we're very integrated with AWS, not just because we're hosted on AWS, but AWS is using Twilio as well. Different cloud providers have different global footprints. And so if you need to be closer to a certain region, sometimes that decision is made for you. And lastly, the different clouds have many different strengths. Okay, and I'll get into a little bit more of that. And so when you first think about multi-cloud, I think the mistake that a lot of people make is this pie-in-the-sky dream. There's this dream that I'll be able to run everything in either cloud, fail over between cloud providers, and by the way, I won't have to rewrite my software. I can abstract the clouds. The reality is you could certainly build your stack on each cloud, but the dream of trying to do it so that it isn't 2x the work or it doesn't completely sacrifice your velocity because now you need to understand both paradigms. I think we're very far away from that. I think perhaps in the next 5 to 10 years we might see something start there, but I think the reality is these are two platforms. And the interesting thing about platforms is that platforms try to differentiate themselves to compete with each other. And so Google and Amazon and Azure are actually working against you trying to do this, okay? So sushi burritos and croissant donuts. Anyone have these things? These are awesome. So you probably are wondering, what does sushi burritos and croissant donuts have to do with multi-cloud? Well, it's is it the best of both worlds? You see, when I have a sushi burrito, is it sushi? Is it a burrito? No, it's really neither, because I have one of those, and I still want to have sushi, and I still want to have a burrito. And croissant donuts, no matter how good the croissant donut gets, I still want my old-fashioned glazed, right? The point is that the cloud is a lot more than just compute, storage, and network. It's the higher level abstractions, it's the higher level services that the cloud provider offers that allows me to do more with less, okay? And so understanding that value proposition that I can do more with less and I don't have to manage fleets of servers. I can use the cloud, right? That is where the value proposition comes in, right? Now, it's interesting, a lot of times you talk to practitioners and they'll be like, well, this is really expensive. I can get my storage at this price per gig instead of what they're charging me. Well, the thing is, once you factor in human capital, you have to be an amazingly massive scale before that starts to make sense. Human capital is very, very, very expensive. If you look at your company's financial statements, if you're public, or sometimes HR will share this with you, the budget for headcount and R&D effort is massive. A lot of times that eclipses the cost of the infrastructure itself that you're serving on. So that's something to take into consideration. The other thing is, even if you factored in your headcount cost and you might be ahead, or let's say you were even, right? Then you really have a terrible business, because the value that you provide as a contributor needs to be more than your salary, right? Like, you're looking for a 10x return. You're looking for a 100x return in terms of company value that you are producing. And that is why these higher level APIs, these higher level cloud services allow you to do more with less, because it's about delivering that value faster. So another value that we have, actually this one I think is called a leadership principle at Twilio. We call it seek progress over perfection. Like it's a fancy way of saying agile, but it's really, it permeates our strategies as well. The point is to get started, because you can't understand everything that you're going to do until you start that process and that journey. And so this is the journey about Google Cloud Platform. So first off, it's one thing that the Amazon regions are very different. The cloud providers are even more different, like really different. So they're so different, in fact, that the way that we went about this, in the spirit of progress over perfection, is we picked a very, very small surface to tackle, to get a very small use case to take Google Cloud for a spin. So I lead a team called Insight Engineering, and we built the next generation log aggregation solution on top of Google Cloud. This is how we got started, some of the building blocks, and some of our experience so far. So you can see there's a lot of cloud services. These are, you have compute and your storage, but you also have some of these higher level services. This slide is actually out of date. There's actually like a whole bunch more that they've just released and stuff like that. But the point is, like, we didn't want to have to go learn all of these, and we didn't need to learn all of these. And so we chose a few of them. And so we chose App Engine. This is for our front end. So front-end apps, small front-end apps built on top of log aggregation. Our back-end persistence is built off of BigQuery. This is kind of like you can put data at rest and pay only 2 cents a gigabyte for data at rest. It's still indexed and searchable. We were able to process some of our early benchmarks. We were able to process like multiple terabytes worth of unstructured data in like 10 to 15 seconds. So it's pretty impressive, the amount of data that you can crunch through these things. We use their storage platform, and we also use their container engine. And so we were getting started, we could just like go straight to containers. The project that we use for containers is actually a chatbot. So we do chat ops at Twilio, and we have this bot called IQ. IQ sits in the chat ops room, but has the power of all the log data behind it. And so you can actually ask IQ arbitrary questions about, like some of the commands to ask questions about the infrastructure, and it will go query and come up with answers for you. Like where are errors and latency propagating through our cluster, right? Twilio has over 600 microservices. The complexity there is pretty hard to grok. You can't look at 600 dashboards, but you can type a command to tell me where all the errors and latency are coming from. And so we use that to help like reduce the cognitive load of some of the complexity that we have. Our high-level architecture, we use FluentD as a client on all of our Amazon boxes with a Kinesis producer library. This emits all the messages to Kinesis. And then we have a very, very small consumer called Sawmill that we transform and route the data into Google BigQuery. And then, like I mentioned, we built small apps on App Engine and Container Engine, and I put Google Sheets up here because this is one of the delightful things we found. If you're logging into the console and using BigQuery, Google Sheets is a first-class integration. And so I could do my query against massive amounts of data, save the results to Google Sheets. It opens it up. Great, I can do more transforms there in Google Sheets. I can go plot it and make a graph, and then click the graph and drop it in the presentation. And so it's all seamless, it's all authenticated because you're all in Google. So, some of the differences that we found. It was really interesting doing this project because since I came from Netflix, I had a fair bit of experience with Amazon. I've gotten to know a lot of the Amazon services, a lot of the both limitations and the trade-offs of Amazon services. and just kind of how to work around the ecosystem of Amazon. And so I come into Google with like, oh, like, what's the equivalent to this? So first off, the APIs are very, very, very different. Any of you guys use gRPC? Okay, gRPC is the open source RPC framework that Google has released. They're starting to support gRPC bindings into some of their cloud services. And so you don't even have to use a REST call. You can use a gRPC. The advantages there are it has like circuit breaking built in. It has things like it persists your connections, so you don't have to stand up and tear down connections every API call. There's a lot of advantages to using gRPC that are pretty interesting. That said, I don't think Amazon's going to support gRPC anytime soon, right? Not everything has an equivalent service. So if you use things like SQS or Kinesis, the Google version of both of those is in one service called PubSub, right? It's very different. The failure modes are different. The way you interact with it is different. The way it gets metered and billed is radically different as well. One of the interesting things we found is in some cases, things that you would do with an API call against one cloud, the way that you do that in the other cloud is a support ticket. So abstracting the cloud becomes very difficult when you have this thing called a support ticket in the way of doing something. Like, I mean, we all joke about eventual consistency, but support tickets are like that. That's not even eventually, right? So the architectures are different. They're deployed differently. The console, I can't if you've ever used the Amazon console, like learning to use the Amazon console takes like months. Now learning another console takes another set of months. And then trying to traverse between the two consoles is just like, the context switch is like, it's a radically different UI paradigm. So this is not just like driving two different cars, okay? This is like driving a race car, driving a boat, or flying a plane. And the only thing that they have in common is that they're modes of transportation, but they're radically, radically different. The controls are different. Everything is different. So one of the other things I want to call out specifically is IAM. IAM is very, very different. So security is very important, right? The last thing you want to do is like, great, I'm multi-cloud, but I've just opened up a huge hacker hole into my infrastructure, right? So you have to really take time to understand the differences in their IAM models, right? They both have IAM, but they're very different, and there's no mapping between them. Like, there's already no mapping between the services. There's really no mapping between their IAM policies, right? The way that you administer the policies, what you can do for them, the capabilities, they're all different, right? Some of the nice things that we found about Google Cloud, if you're using Google for work, like Gmail at work, Google Cloud, the Google console uses that authentication, that identity and authentication. So we didn't have to go create all users. Like, we could actually, there's already an engineering org inside of Gmail that we use. Like, we can actually assign permissions based on that. So that was pretty nice. Google also has a quota system that's pretty interesting. So we could actually say, like, imagine your hack week and you just want to let developers loose, right? We can actually say, hey, every developer now has $100 to spend this week for Hack Week in Google Cloud. Go crazy, use whatever you want. But the system will not let you use more than $100, right? So they actually have quota systems built at the user level. That's pretty impressive. Some of the other differences, testing out the network connectivity between clouds. So, you don't have to be like this hacker with a hoodie to figure this out. A few trace routes actually reveal this. Google and Amazon's networks are extremely close. In most cases, they're a single hop away, meaning that they're peered together. That said, it's still a network and still has different connectivity issues from time to time. The other thing that's interesting is because you have two different companies there, there's not one company that's like trying to maintain connectivity between your regions. And so if in Amazon, it's like, I can go to Amazon and say, hey, like your connectivity between East and West is like having some problems. Great, we'll page the team and take a look at it. If I go to Amazon and say, hey, your connectivity to Google Cloud's like not very good, I don't think they're gonna do very much, right? Google Cloud might because they're trying to get more business and market share, but Amazon's definitely not going to, right? So one of the other cool things that we found, so Google Cloud Storage has cloud transfer as a service. So we had all this data in S3, and we're like, how do we get the data over? And so we start using the cloud console, and we found like, oh, like there's this thing that's transfer. And so we click it, and there's literally a 3-step form inside of Google Cloud's console that allows you to transfer from a Amazon S3 bucket. You have to give it creds, you have to give it the correct creds and access and the paths. But the impressive thing was when we did that, it actually downloaded the entire S3 bucket faster than we could download it in EC2. In fact, we couldn't even list the bucket that fast. So the pipe between the clouds is actually very, very large, very fast. So cross-cloud communication, I think this is one of the things that we haven't figured, we don't have a good solution for this yet. We're using external endpoints, and so we're just hitting the external endpoint to write into BigQuery. But there's other options that we've been playing with. So Google has VPN gateways as a service, and so if you have VPNs to enter your VPC, you can actually connect the VPNs, and it's managed for you, and so you have a network path between them. Some of the other things, but then you have to worry about security groups. I'm not sure how that works, right? And then, like, if you have a microservice architecture and have like service discovery, like that becomes a pretty interesting challenge as well across clouds. And then for anyone using Amazon Linux, the Amazon Linux AMIs, like, we haven't tried it, but I'm pretty sure Google's not going to support Amazon Linux. And so you definitely want to use something like CentOS, Ubuntu, Red Hat, one of those like third-party ones that both are going to support. But for us, since we were starting new and it was a very simple use case, we actually just started with containers directly from the start. So a recap on multi-cloud: start small, right? Your CEO, CMO, or CTO might be like, multi-cloud everything, and it's like, well, how do we get started? Like, can we pick something smaller than rewriting the whole stack? Because when you get started small, like, trust me, they're so different that you will learn something. You will learn something very, very valuable that will help inform your strategy for whatever you're going to do later, right? And so you want to try and figure those things out with the least amount of surface and as least risk as possible. The APIs are different, very, very different. Can't stress how different they are. Like, I will say, like, when you encounter the differences, like, oh, I can do an API call here, and then you get to the other cloud, and you're like, oh, I got to log a support ticket. Like, and it goes both ways. So I'm not trying to pick on one or the other. Like, they're just different. It's just like, oh, like, I wish you had APIs for this. And you're like, yeah, it's coming, right? Security. It's very, very important. Talk to your security team before you even get started. The security models on how you secure the public cloud providers are very different. Securing one public cloud provider is actually pretty hard. It's not trivial. It takes a lot of work. Securing 2 public cloud providers and making sure that you can talk to each of them and securing that is a whole lot more work as well. Okay. So another leadership principle that we have at Twilio, we like to call it leave teams as their legacies. The point is that, like, as leaders, we look for, like, the team should live on beyond my existence. And I was fortunate enough that, I left chaos engineering at Netflix, and their work continues. You still see tech blogs, you still see tech talks, you still hear about chaos engineering and what they're doing, which is fantastic. And now I get to take part in the beginnings of another legendary team, platform engineering at Twilio, because these are the problems that we have to solve. These are the problem space that we're tackling. And so, obviously, everyone's hiring. If any of these challenges are specifically interesting to you, definitely come find me later. We're definitely hiring across all of our teams, heavily hiring in platforms. So you hear about the international expansion for companies like Uber, Airbnb. And not only does Twilio power companies like Uber and Airbnb, we also power companies like this that you might not have heard of. The Polaris Project built an app called Be Free. And Be Free was built for the purpose of rescuing victims of human trafficking. Trek Medics International built a community-powered emergency medical response systems for countries that don't have 911 infrastructure. You see, third world countries, it's not that they don't have doctors, it's they don't have communications infrastructure to access that emergency medical response. And so Trek Medics built an SMS app. It's community driven, and people sign up with the different skills that they have, and someone has an emergency, and they broadcast it out. Crisis Text Line is, Crisis Text Line responds to text messages to people reaching out in crisis, right? And to quote founder and CEO Nancy Lublin, Crisis Text Line dispatches active rescues 8 times a day. You see, lives are changed, lives are saved thanks to companies like this, right? That is why we have to be multi-cloud. That is why we have to be multi-region. Thank you. I think I'll be around for questions if you guys want to ask any. Yeah, so the question is, we have, from a technical standpoint, we have 7 different regions. How do you connect them together? So there's multiple different ways to connect them. You can encrypt and proxy traffic over the open internet. We actually found that if you do trace routes between them, they're actually interconnected pretty well already. So it's not the open internet, it's like Amazon's backbone. The other way that you can do this is actually direct connect. So if you're in VPC, you can use direct connects. And for Twilio, we actually run a mesh network setup where we have routers that go out of every single VPC and mesh to all the other ones. So, and we actually use a combination of both of those things to separate media and control plane, actually.
So when you send data across to a different cloud vendor, how do you justify the cost of sending the data out of a cloud vendor to a different cloud vendor? Because you are not just paying for the infrastructure cost in another cloud vendor, but also the egress of the data.
Yes.
How do you justify that cost?
Yeah. So the question is how do you justify the network egress costs of connecting 2 clouds? So the interesting thing is if you stay in Amazon and you go region to region, you still pay egress cost. So it's interesting. The cost for me to go from an AWS region to an AWS region is equal to that of going from an AWS region to Google Cloud. So that already helps the equation a lot. Since I've actually tried to get Amazon to give us a discount on region to region traffic, but they haven't gone for it yet. The other justification here is, I didn't mention it in the talk, but everyone thinks about this in multi-cloud, is you get negotiation power. So you get negotiation power with your cloud providers, right? Because they're trying to get more and more of your business. And so they're the short-term answer is well, you're equal to that of region to region anyways. The longer term answer is that as you scale and as you develop this, and if you're large enough, you actually have significant business and negotiating power with your cloud providers.
Thank you. My second question, how do you evaluate the overall quality of Google services, especially their PubSub system?
Great question. I used to work with Alan. I know he works on Kafka. So his question is, how do you evaluate PubSub? To be honest, I haven't evaluated PubSub yet. We looked at it. It's one of those things we looked at. We even looked at trying to have Kinesis talk straight into PubSub and then go into BigQuery, but then at that rate, we're not only paying for egress, then we would be paying for Kinesis and PubSub, which was just that definitely wasn't economical. I think at the point at which we have more of a footprint of actually serving voice traffic or something like that, or a control plane inside of Google Cloud, then it obviously we're not going to use Kinesis we're not going to go Kinesis from Google to Kinesis to BigQuery. We're going to go Google Cloud to PubSub to BigQuery. And so talk to me in 9 months, and I'll have a better answer for you.
Thank you.
So when it comes to making a decision about going multi-cloud, is that something that you find that you're doing within the same application, or you're picking an application and deciding which cloud to run it on?
Yeah, that's a great question. So the question is about how do you choose which cloud that you're going to do, or if you're going to do multi-cloud. At this point, we're really, really early in the journey. So this is the first thing that we've done. And really the way we've been thinking about this is pick very, very small pilots that can live as islands that don't need to interconnect first, and come up with good KPIs to do comparison analysis. So we can actually compare, for example, if we stood up the voice stack inside of Google Cloud, we could compare the voice quality between the different cloud providers. We can compare the network quality and stuff like that. And so, I think it's figuring out how to scope the problem as small as possible is my best recommendation there. My other recommendation is don't do it unless you have a business driver. Don't do multi-cloud for the sake of doing multi-cloud. Do it because you actually have a driver for that.
I guess the other part was, so is it what you've done so far, at least, is it that you're taking an application and saying this application is great in Amazon, or it's great in Google, or this application is great spread across Amazon and Google? Do you have apps that are actually, that specific app is multi-cloud, or just some apps are in one and some apps are in another?
Yeah, so currently the only app that's actually multi-cloud is the log aggregation system. So none of the production Twilio service is actually multi-cloud at this point. We're getting started. We have some goals around seeing what we can do, but at this point it's just the log aggregation system. So that being said, since all the data is in Google Cloud, any new Insight apps that my team builds is also going to be in Google Cloud for the egress perspective. So there's also some interesting failure zone benefits that we get. So if Amazon goes down, we're not completely blind unless we can't get stuff out of Amazon. So.
Yeah, because most of what you said, whether it's intentional, is sort of an argument against being multi-cloud within a single app.
Right.
Because of security and this and that, different services.
Yeah, that's why I'm saying don't do it unless you have a really good business driver. So.
When you were evaluating, when Amazon, different geographical locations you said had different performances or different clouds when you're comparing them, did you use any toolkits like the PerfKit benchmarker, or was there anything you did besides typical Unix commands and?
Yeah, I think the reality for us is that real-time media is very latency sensitive. So, for example, if I'm a website and it takes me 2 extra seconds to load your website in Asia, it's not great, but it's okay. But if you have a 2-second lag on a phone call for your voice, that's unusable. And so the reality is the performance gain that we get, it's easy to measure because it's okay, are you crossing the Atlantic or are you going local, right? It's just going to be better because of the network topology, right? And so that's the reason why we're multi-region. and have a global footprint because of Twilio itself is a very latency sensitive application. So does that kind of answer your question?
I guess I meant more of like comparing a VM and a region in cloud provider A versus B.
Yeah, for that we actually just we do initial benchmarking to make sure like nothing's like terribly wrong, but like we actually use production load to actually like take a look at those things. So and as well as like for us, there's actually some requirements from our carriers that we need to be local to, like close enough to them to actually peer with them. So.
Do you mind explaining your direct connect setup a little bit more? How are you guys then purchasing private transit between regions, or?
Yeah, so we actually have a couple POPs in Equinix that we direct connect into those, and then we connect those together. Yeah, that's a pretty early project too that we've been getting started, and so, I imagine like the amount of POPs that we'll be in, it will be expanding pretty rapidly over the next few years. Awesome. Well, thank you for coming. It's been a pleasure meeting you guys. And if you guys have any other questions, feel free to come grab me afterwards. Thank you.